Good morning. Welcome back to my tutorial. And now we are in cables. Specifically, we are going to analyze and calculate the requirements for the suspension bridge being, supported with this cable IH. So you have here our task is to determine the maximum tension in the cable IH, by which the shape is in parabolic. And then the bridge is subjected to a single load of 50 kilonewton. Okay, so let's start. So if you are going to draw the free body diagram of this, we can have this. Okay, so we sum up moment. We sum up moment here at B. So summation of moment at B equals to 0. So we have here first, let us say our direction is clockwise, like this to be positive. So as you can see here, IY and AY is going in this direction. Okay, clockwise, it's clockwise. So the perpendicular distance is this one. Okay, 24. The same also for IY, it is also 24. Okay, so let's start with IY. You have IY times 24, and then this one AY is also equal to 24. Okay, and then you have here 50. This is in the counterclockwise direction. So you have that becomes minus 50 times distance is equal to 9. Okay, equals to 0. Okay, so I can have IY 24, and then 24 AY. Okay, and then this one will put on the right side from negative becomes positive. So this is just 50 times 9. This is actually 450. Okay, if this is 450, I could write it on the right side from negative will become positive. Divide both sides by 24 and also this one by 24. It follows that you have here IY plus AY is equal to, let's see, get a calculator. You have 18.75. This will be our first equation. Okay, then next, if we cut this section, okay, at this point, and then we consider the left side, we can have this diagram. Okay, so from here, we can have moment again C, take moment at C. Our purpose is so that we have the same unknown AY and then IY, and by that we can eliminate AY and IY, and we can compute for FH. So summation moment at C. Okay, so IY and AY is in the clockwise direction. So we can say that uh, here we start with IY. Okay, IY times 12, and then plus AY times 12. Okay, now you have your FH. This is FH is in the counterclockwise direction. So you have minus FH multiplied by distance is 14, and then this one another FH is in this direction. So you have plus FH times 6. Okay, so we have 12 IY, and then this IY plus 12 AY, and then okay, this one I'm going to move it to the right. That's FH, and then 14, and then positive become minus FH and 6. So this part we can simplify or factor out FH. That is just 14 minus 6. In other words, we have here 12. This is IY plus 12 AY. 14 minus 6 is equal to 8 FH. Now divide both sides by 12. Okay, 12, 12. I will just write it here, okay? This is IY plus AY equals to 2/3 or 0.667 FH. This will be our equation 2. Okay, now in our first equation, if we have this IY plus AY is equal to 18.75. And then the equation 2, you have here IY plus AY is equal to 0.667 FH. This is equation 1 and this is equation 2. One thing that we can notice here is that this one and this one are equal. So meaning we can just equate 18.75 to that of 0.667 FH, which is, in other words, if you divide both sides by 0.667 and then you have your 0.667 FH could be calculated as 28.125. This is kilonewton. Okay. Now we have the formula of WO. WO or sub O is equal to 2 FH and then H all over L squared. Okay, take note that okay, in our given drawing, I'll just copy it again and put it here on the side so that we can have our reference. Okay, from here, okay, we know that our H, this is our H, which is just the height of this, or the sag of the cable from this point, right? And this will be our L, which is equal to 12. So substitute, you have 2 FH, we already calculated to be 28.125, okay, kilonewton. And then H, or the height, which is equal to this one, 8 meters. 8 meters. And then you have L, which is 12 meters squared. So WO is just equal to 3.125 kilonewton meter. Now we can compute Tmax because we have this formula. This is the maximum tension of the cable is equal to WO L 1 plus L over 2H squared. So we can substitute WO is 3.125, L is equal to 12. You have your 1, okay, plus L is equal to 12, okay, and then you have 2 times 8 is our H, and then you have squared, okay. H is here 8, and then L is this one. So Tmax shall be equal to 46.9 kilonewton. Okay, so that's all for this video. Follow and share this video with your friends. See you in the next tutorial.